about the shift from just thinking individually, the computational thinking, to computational participation. And why is it that I think what we did 30 years ago is actually of relevance today? And I think we can actually use these three lenses from Seymour Papert theory to review the research and what we had in computer science education in K-12 and articulate what I call a social shift in how we think differently about teaching. There's three different shifts: personal, social, and cultural, and I'll explain a little bit more what I mean. So the first shift from code to application is, when I look at a lot of the research over the last 30 years, there's a big emphasis on how students learn how to code. And that's a kind of standard, kind of written text. Nowadays, of course, we have a lot of visual programming language. This is an example from the Scratch programming tool, which I helped to develop with Mitch Resnick's group at MIT. But there really was this focus on learning to code for the sake of coding. To me, it didn't really matter which kind of language you use. So the big shift has really been, we're not just learning to code for the sake of coding, we're actually learning to code to create applications. So the fraction games which you saw in the video were one example. You can think about other educational software, and nowadays creating an app is probably the hardest thing you can do, whether you use App Inventor or anything else. Apps are those little programs which you have. I mean, there are hundreds, thousands of them, whether it's for the iPhone or for Android. Everything is kind of interfaced through applications. Providing a context which is authentic, because that's the technology we're using, which is personally relevant, so we can situate the teaching of code, not just in the abstract, but making it concrete and relevant. I didn't showcase you the evaluations which we ran with pre- and post-test. Both Edith Harrell, who did the first instructional software design project where kids created educational software, and in my case, where students created educational games. And they actually showed very convincingly, when we compared these students to other students in the same school, we matched them in terms of gender as well as proficiency. And those students who programmed the same amount of time but who didn't create applications, and those students who only went once a week into the computer lab, we could not only show they learned significantly better programming, both from constructing as well as debugging, but also their mathematics skill increased because they had a context in which to situate their learning of math or fractions by representing and explaining it to other students in their school. A second shift, which I think is equally important, there's a lot of focus on programming languages. So Logo alone, there's over 200 versions of it nowadays, and still more are being generated. We have lots of different programming tools, and I think it's because programmers, computer scientists, love to design programming language. There's an art in doing this. I can attest to this. When we designed Scratch, we thought very carefully of all the features, how the colors were, how everything is arranged. In particular, if you design programming languages for novices, for beginners, equally important, of course, this is in a professional context. But I think for the last 30 years, we have focused too much on just the tools. We also need to think about the communities. And Scratch is a really great example. We designed it first as a tool and tested it and implemented it in many of the computer clubhouses in the United States. And then in 2007, when it actually was released, it wasn't just released as a programming tool, it also came with a community, because there's a button on the Scratch screen which you press and you upload your community, your program, to a server at MIT. And very little did we know at the time how successful this will be. By the way, Scratch was actually, the community was first called Scratcher in reference to Flickr, the photo sharing community. But it's not just a place, if you go and if some of you have been at the Scratch community, where there are now millions of programs. I think every minute I'm talking, a new program is being uploaded, has been translated in over 25 languages. And it's probably one, of the largest used programming communities. There's also a lot of the kind of social networking you see on places like Facebook, Twine, Tumblr going on. So kids are not just programming, they're also exchanging. And I think that actually explains, it's not the only reason, the success of Scratch. Kids in this today's society not just want to produce, they also want to share what they're doing and interact with others. So I would argue the next shift, the next feature we need to pay attention to is in which context the coding takes place for what it's being done. And secondly, that we have a social context. For those of you who are old-time Noble people and teachers, who will argue, well, the classrooms were always communities. A good teacher always figured out not just to have kids program individually, but have them look at each other's program and change. But now that we have the online platform, we have actually another opportunity to kind of create these exchanges and connection and make them relevant, not just to yourself, but also to others. And finally, we also need a cultural shift. This is no pun intended from Scratch to Remix, but there's this idea in particular in the early days that you really need to start writing your program from a blank page, Scratch. But the reality today is when people write programs, they really write from scratch. They go immediately onto the internet to GitHub or any places and see who else has already written something, and then I can see whether I can use it. And this notion of remixing is actually very deeply embedded in youth culture. If you look at music, remixing, if you look at graphics. So remixing is actually a cultural practice today. And on the Scratch community, remixing, I think over 34% of all projects are remixes, a large part. And Andres Onroy Menendez, who created the Scratch community as his master's thesis for his dissertation, did some really nice work on looking at different forms of remixes. Obviously, if you just cut and paste the code and then say that's mine, there's not a lot to be gained intellectually. And then the copycat police will come after you because you just copied code without giving acknowledgement to the creditor. But as he found when he studied different programs, there are actually remix trees of every program. You can see who has taken the code, appropriated it, and that there actually also were examples of what he called creative remixes, where people took an idea and took it in a different direction. So I think, realistically, we can actually use remix also as a teaching strategy. It's, of course, a little bit at odds with school culture, because every time when kids copy in school, it's kind of considered cheating. But this is, again, a shift which we have to undertake if we want to think about teaching programming, not just in a meaningful way, but also in a social and personally responsible way. So Quinn Burke, who was one of my graduate students, and I, when we wrote Connected Code, we're not in disagreement with computational thinking on what it has to offer in terms of a general definition. But we think we should move away from this perception that programming is this lonely activity. The guys who sit in the basement, they don't talk to really anybody, and they're greasy-haired and pimpled and all of that. No, it's part of social practice. It's really a common practice which allows kids to participate in the network world, and Scratch is one example of it. So that's what I mean by computational participation. It is about coding, but with a purpose, for an application. It's done within a social context for sharing. It involves practices which are common in today's culture.